Okay, guys, in this example, we are going to go over an inscribed shaped example. And it says that a rectangle is to be inscribed. The word inscribed simply means that the vertices are enclosed by a particular curve. This one is enclosed in the sine curve, or the one arch of the sine curve from 0 to pi. So I have here my sine curve drawn, and what I'm going to do is go ahead and draw a rectangle that is enclosed in it. So that means that the vertices hit the curve, and then you make this rectangle. So this is an inscribed rectangle, and I didn't draw a very good axis here at the bottom, but this is supposed to be a nice rectangle that has 90-degree angles. So let's go ahead and continue reading the problem. What is the largest area the rectangle can have, and what dimensions will give that area? So we are maximizing, in this case, the area of this rectangle. And so the area of a rectangle is just base times height. So when it comes to creating an equation, we're going to have to create an equation that's just the base times the height. Then in order to do that, we're going to have to label some things on this picture. So let me use my blue. Well, let's use a different color, green. So the first thing I want you to understand is that because the temptation is just to say, hey, this is X and this is Y. But it doesn't work quite like that. Because we are on the XY coordinate plane, it's important that you understand what X and Y mean. When you use the variable X, that's going to mean the distance that you are traveling from the origin. So it cannot just be that the bottom of the rectangle, this side, is X, because we are on the coordinate plane, X really represents the distance that you are from the origin. So really, if we wanted to, this from the start of this rectangle to the origin, that's what X would be, okay? It's how far you are from that origin. Now, because this is all symmetrical, sine curve is symmetrical, the rectangle is symmetrical, this space and this space over here are the same. So whatever X is, let's say it was 2, this would also be 2. So for now, we're going to call this side X as well. Okay? Now, if I wanted to know then the length of the rectangle itself, you will note that from the origin all the way to this x-intercept here, the distance from the origin to that point is pi. If we take out the x's, what's left over is the length of that rectangle, which would be pi minus 2x. So if x is the distance from the origin to the rectangle, all right, that will be the same distance from the rectangle to the intercept, because of symmetry, and the entire distance is pi, I'm going to take away these x's, there's 2 of them, and that will be the side of the rectangle, the bottom side of the rectangle. So now it's time to figure out this piece. Well, this piece is always going to be determined by the curve itself. And you're right, the distance between this point and the x-axis is going to be y. That's what y represents, how far you are from that x-axis. So because this is y, you can also take it to mean you know what y equals. Y is always going to equal the sine curve. So no matter what x you pick, your vertex is going to lie on that sine curve, and the distance between the sine curve and the axis is going to be y. And y is going to be given by the curve sine of x. So we have all the elements we need. It's time to build our equation. So the area of this rectangle is going to be the base. That's going to be pi minus 2x times the height, which is going to be sine of x. And this is our equation. Notice that it's already in one variable. So that's perfect. I don't really need to go look for anything else. I'm going to go ahead and set the derivative equal to 0. And again, I will use my graphing calculator to do that. And I come out with x is equal to 0.7105. And then you have to test it. If you use your graphing calculator, and you know why I didn't talk about the domain, let's talk about the domain. What is the smallest possible value of x? Well, if we shrink all this x to the origin, the smallest possible value would be 0. And imagine what that would look like. You would have a really long base on this box. But your height would be 0 because your you are basically, you have no height on this rectangle. And then you're going to want to say, well, what if we made x really tiny, like really big? Since you have two x's, one in here, one in here, if you ended up making these bigger, they would meet in the middle and essentially just be one long line here. And that would be, the length of each side would be pi, but there's two of them, so it would be pi over 2. So that means our answer is in between 0 and pi halves. So I know 0 and pi halves are my boundaries here. And my answer, 0.71, that's my CP. You check your graph. Since it's a max area, you should get a plus going up for the prime, the A prime, and a negative, which means coming down. That would give you that max area. And so now you have to make sure you answer the question. What were the dimensions? The dimensions are going to be pi minus 2x and sine of x. So we need to make sure we get those right. I believe those come out to 1.7207 by 0.6522. Okay, so pi minus 2x, x being this decimal here, and sine of that decimal should give us these. And then the area itself computed is 1.1222. And all I'm doing is plugging that x back into my area equation. And that's how you deal with these. So hope that made sense. And now you can try out your assignment.